All right, this is Advanced Algebra 1, and we're looking at Topic 5, Section 3, which are what we call the step function. Start off, what I like to look at is what I call the taxi cab problem. And I have f of t, the function with respect to time, equals 8 plus 10t. Okay? So what that function means is if I want to calculate what somebody has to pay me to ride in my taxi cab, they're going to pay an $8 flat fee. So no matter where I take them, or how far, how long, $8. Okay. And then I'm going to charge them $10 per each hour. Okay. So, you look at this equation and you think, well, linear, right? Linear. I'm actually going to count by 10 here. That's going to be 10, 20, 30, 40, 50. And I'm going to count by 1 going this way. 1, 2, 3, 4, 5, 6. Okay. This is going to be the number of hours that you're in my cab. And this is going to be the money. Okay, how much money you're going to pay me. So I'm going along in my cab. It says that even if I'm at 0 time, you're going to pay $8. Okay, so that means my graph's going to start right here, slightly below the 10 at $8. And then after an hour, you now owe me $18. Okay. And if we tried to draw this as a line where I rise 10 and I run 1, and I rise 10 and I run 1, and I try to draw that as a line, okay, drawing it in real light. If I try to draw this as a line, then what that's telling me is that at a half an hour, I don't owe you $18, I only owe you this many dollars. Or at 3.5 hours, I don't owe you whatever it should be, I owe you this amount of money. Okay, and that's not truthful to the scenario. Okay, you're going to pay $8 until we hit that hour. So what it looks like is we draw a line over here, and then I put an open circle on 1, and as soon as I hit 1, I'm going to add $10 to my charge. So now I'm at 18. Okay. And I'm at $18 all the way through here until I hit 2 hours. And then at 2 hours, it's going to jump up to $28. So now I'm at $28, and it's going to stay $28 all the way over to here until I hit 3 hours. And then it's going to jump up to $38. And so this is what we call a step function. Okay. The reason we call them step functions is because they look like a staircase, right? And we can keep going here. Goes to that, goes to that, goes to that, and we could go this way too if it applied. Step functions, this book has 2 different categories. They say that one category is what they call the ceiling function, and the other category is what they call the floor function. And the ceiling function is denoted as like an incomplete bracket, and the floor function is indicated as a lower incomplete bracket. Okay. Now, if I were to make a chart for my taxi cab problem of X, or let's use time, right? Time and money. At 0 hours, I'm paying $8. That's the flat fee. At 0.5 hours, I'm paying $8. At 0.9 hours, I'm paying $8. At 1 hour, I'm paying 10. And at 1.5 hours, I'm paying 10. Okay. So this would be a ceiling function because it jumps up. The floor function jumps down. Okay. And we'll look at examples of those. So in this next function, on this next page, I have the step function is defined, the piecewise defined function that consists of constant pieces. The graph resembles a set of steps. So is it a continuous function? No. Ceiling function is a kind of step function. It rounds numbers up to the nearest integer. It is notated f of x equals ceiling x, or f of x equals, like I said, that, the incomplete bracket thing. A floor function is another type of step function. It rounds numbers down to the nearest integer, and it is denoted as such. Okay. So some of what they're going to have you doing basically is making, they're going to ask you for function values. Okay. So this particular example, I have our ceiling function. Okay. This is the ceiling function of the type of step function that it is. So if I plug in numbers, okay, if I plug in negative 2.4, what's the integer up from that? The next integer up from that. And so a lot of people want to go negative 3, but remember negative 3 is smaller. So the answer here would be negative 2. So f of negative 2.4 is negative 2. F of negative 1.4 is negative 1. F of negative 0.5 is 0. F of 0.7 is 1. F of 0.9 is 1. F of 1.1 is 2. F of 1.8 is 2. F of 1.9 is 2. F of 2 is 2. F of 2.1 is 3. F of 2.4 is 3. You know, and we could just keep going on forever and ever and ever. How do I graph that? Well, if I start at negative 2.4, negative 2.4 is here, and the integer closest to it is negative 2. So that means that this is my open circle, this is my closed circle. And so then at negative 2, I jump up to negative 1, open on the left, close on the right. And I do that again. And basically open to close. Then jump, open to close. Then jump, open to close. And then jump, open to close. And we could go on like that forever. So then for the floor function, if we were to make a chart of values for the floor function, the notation is like this. This is the, we're going to have a pencil issue here. This is the floor function. So that means when I have an integer, if I put in 1/2, I go down now. What's the next integer down from 1/2? It's 0. If I put in 3/4, I get 0. If I put in 0, I get 0. If I put in 1, I get 1. If I put in 1.1, I get 1. If I put in 1.6, I get 1. If I put in 1.9, I get 1. If I put in 2, I get 2. If I put in 2.5, I get 2. So the floor function, if I start at 0, and everything here, it's going to be 0 until I get to 1, and then when I get to 1, it's going to jump up to 1. So closed circle on the left to open circle on the right. And we can just continue in that manner. Okay. The domain is actually the set of integers. I'm sorry, the range is actually the set of integers. The domain would be difficult to express in these problems. Going this way, I have an open circle here to a closed circle here, open, over, and so on. That's the floor function. Floor function, what I plug in, I go down to the integer. The ceiling function, if this were in the ceiling function and I plug in 1.9, I would get 2. Okay, so that's what we have going on with that one.